Excuse me, John. I'm having a little trouble with the redox worksheet. Just getting started with identifying what's being redoxed and what's being oxidized. So can you help me out?
Yeah, absolutely. So what do you already know about oxidation and reduction?
So I know that it involves transfer of electrons, and that reduction is gaining electrons and oxidation is losing electrons.
Okay, you got the right idea. Now the next step with that would be seeing where the electrons are moving in the reaction.
So in here it says for the zinc it's going from neutral to 2 positive.
Mm-hmm.
So I think that means that it's gaining 2 electrons.
Okay, you know the right number, but what charge are electrons?
Negative charges?
Yeah, they're negative charges. So zinc is going from 0 to +2, and electrons are negative, then is zinc gaining those negatives or losing them?
So then it means it's losing electrons. So does that mean it's actually getting oxidized?
Yeah, it's being oxidized because it's losing those electrons. And remember, redox always happens in pairs. So if zinc is being oxidized, what must be happening to the copper?
So copper is going from +2 to 0, so it's gaining electrons which are negatively charged, meaning that it's reduced.
Yes, perfect. Okay, now the next step is going to be the same way on the rest of this worksheet. We have to identify oxidizing and reducing agents.
Yes.
So what are they?
So oxidizing agent oxidizes other atoms and reducing agent reduces other atoms. So that means that because zinc is being oxidized in here, that copper is the oxidizing agent, and which makes zinc the reducing agent.
Yeah, that's perfect.
Yeah.
Okay, so I'm having trouble. It's asking me to write half reactions for oxidation and reduction, and I'm honestly not sure what I'm supposed to do.
Okay, so the first step is to identify what's being oxidized and what's being reduced, which you already did, so you're on the right track.
Yep.
Now we have a special way to write each of those, and that's what with a half reaction. In a reduction half reaction, an atom is gaining electron, remember Rieger-Gurr.
Yep.
The first thing you do is split the reaction into 2 elements, so make a reaction equation for copper and make one for zinc.
Okay, so we would have to have 2 equations. We have to have 2 equations. We need copper 2 plus on the left for, oh boy, going from plus, it's gaining electrons. The reducing half reaction would be copper to copper solid, right? Okay.
So let's try that. So reduction half.
Okay. Yeah. And then the oxidation one would just be the zinc solid to the zinc 2 plus.
You're right. So the next step is looking for where to put electrons to balance. Take the zinc first, look at the charges and tell me where you think electrons should go.
The zinc, right? Okay. So since we're going from neutral zinc, the solid form, to 2 plus, I feel like we would need 2 electrons on that side to even everything out, to like go back, like cancel out and get to neutral.
That's correct. And how many electrons should be there to balance it out?
Well, we would need 2, right? Because electrons are -1.
Exactly.
Okay.
So what do you think for copper? Now look at the copper side.
I feel like they should go on the left side, but I don't know why.
So it's the same thing, like how you made this neutral to make the charge equal on the both sides. You see the charge is on your left side, so we need electrons on our left.
Yeah, okay, that makes sense.
So how many electrons do we need to balance it out?
We would need 2, right? I mean, it's the same charge. Okay, cool.
That's correct.
Perfect.
Thank you, John.
Yeah, what's up?
There's one more example that I'm confused about involving organic molecules.
Okay, yep.
So the reaction is 2-butanol and NaOCl going to 2-butan-1 salt and water.
Okay, so organic molecules, especially when they're not super obvious with the charges, they're trickier. But another way we can think about redox is about hydrogen and oxygen bonds. So oxidation, as the name kind of implies, if you gain bonds to O's, Alternatively, you can lose bonds to hydrogens. So thinking about that, in the opposite being reduction, what do you think reduction is?
So if it gains hydrogen or loses oxygen bonds, that it's being reduced.
Yeah, perfect. So looking at the reaction, first it'll probably be easier to identify what's being oxidized. So when you look at this, what's the red flag?
So it's that new oxygen bond. Does that mean that the ketone is being reduced?
Okay, like when we were doing acid bases, when we identified base and conjugate acid, I understand why you want to do that, but we can't do that with oxidation reduction. So I want you to just focus on the reactants. Ignore the products. So what do you think is happening to the reactants?
So in order to be reduced, you either have to gain hydrogen or lose oxygen. So the NaOCl in there is losing those bonds to oxygen, meaning that it's being reduced.
Yeah, that's absolutely right. And if you wanted to take this further, you could split them up into half reactions, but I feel like you got a lot of practice with that already.
I'm going to try that. Thank you.